Fall Semester Exam Review Part 2. Transformations, page 1. So here are all your rules for vertical, horizontal translations that we need to follow to answer our questions. Number 1, the function g of x equals to f of x plus 3 is a transformation of the parent function f of x equals to x. Describe the transformation. So inside the parentheses we have the x plus 3, so I'm going to look for the rule that has that. It's the c value. That means it's going to translate c units to the left. So therefore g of x translates 3 units to the left. Number 2, the function g of x equals to f of x minus 4 is a transformation of the parent function f of x equals to x. Describe the transformation. Minus 4 is outside f of x, so that's this one right here. So it means we're going to translate d units down. So g of x translates 4 units down. Page 2, number 3, the function g of x equals to f of x minus 2 is a transformation of the parent function f of x equals to x. Describe the transformation. Minus 2 is inside the parentheses, so that matches to this rule right here, minus c. That means we're going to translate it c units right. So therefore g of x translates 2 units right. Number 4, g of x equals to f of x plus 5 is a transformation of the parent function f of x equals to x. Describe the transformation. Plus 5, that's this plus d value outside the parentheses, so you're going to translate it d units up. So therefore g of x translates 5 units up. Number 5, the function g of x equals to 2 times f of x is a transformation of the parent function f of x equals to x. Describe the transformation. So we have 2 f of x's, so that is this one right here, a times f of x. The a value in our problem is 2, so that means our a value is greater than 1. So that means it's going to be a horizontal stretch, and the line, it's going to get a steeper line. We're going to have a steeper slope. So therefore g of x is a vertical stretch and has a steeper line. Number 6, the function g of x equals to f of 1/2 x is a transformation of the parent function f of x equals to x. Describe the transformation. So inside the parentheses we have 1/2 times x. So that means it's this one right here, the b value. So the b value is 1/2. That means the b value is not greater than 1. It is between 0 and 1, which means that this will be a horizontal stretch with a less steep line. So g of x is a horizontal stretch, and the line is less steep. Number 7, the function g of x equals to f of negative x plus 2 is a transformation of the parent function f of x equals to x. Describe the transformation. So inside the parentheses we have a negative x, which is this one right here. So that means the rule is you're going to reflect it across the y-axis. And the plus 2 means that we're going to translate it d units up. So g of x reflects across the y-axis and translates 2 units up. Page 3, direct variation. If y varies directly with x, then the value of x increases. Then as the value of x increases, the value of y is also increasing. And y equals to k times x, where y is your constant of variation. It's also your slope. Constant of variation k is referred to your slope. In slope-intercept form, the equation would look like this. Y equals to mx. The y-intercept is going to be 0 because it's going to go through the origin. Another name for a direct variation is proportional. And then here's your formula to find your constant of variation, or the slope, for a direct variation problem. So let's go and look at number 1. The value y varies directly with x. These are the words you're looking for to determine if it's a direct variation problem. Write a function to represent the relationship between x and y if y equals to 20/3 when x equals to 30. So we know what the y value is and the x value, so we need to find our constant of variation. So k is equal to y divided by x. The y value is 20/3, and then the x value is 30. So this means what's 20/3 divided by 30? Remember, this means divided by. So I'm going to go and work it out the long way. 20/3 divided by 30. So you have to remember your rules of division. Division changes to multiplication. 30 changes to the reciprocal, which is 1/30. And then now you just multiply across. 20 times 1, 20. 3 times 30, 90. 20/90 simplifies to 2/9. So there's your constant of variation. So y equals to 2/9 times x. Now remember, you can always use your calculator to double check your math. Make sure you're doing the problem correctly. So we need to figure out what 20/3 divided by 30 over 1 is. So you have 20/3 divided by 30. And we get 2/9. You did it correct. Always double check your work. The amount of money Ricky charges for his lawn service varies directly with the number of hours he takes to complete the job. That means the amount of money is your y and the number of hours is your x. If Ricky charges $105 for a 3-hour job, how much money would he charge for a job that took 5 hours? So what's our constant of variation? Y divided by x. So our number of hours represents our y, the amount he's going to charge, So it's $105 divided by the number of hours, x. So what's 105 divided by 3? 105 divided by 3 will give us $35. So this means that he will charge $35 per hour. So now we need to find out, well, how much is he going to charge for a job that took 5 hours from the work? So that means that it's 35 times 5 hours. So work that out. 35 times 5, we end up with 175. So he will charge $175. Page 4, parallel and perpendicular lines. Two lines are parallel if they lie on the same plane and have no points in common. The lines will never intersect, and lines are parallel, have the same slopes, have slopes that are the same. So remember, parallel lines are lines that never intersect. Circle the lines that are parallel. The first one, the slope is -2, slope is 3, slope is -2. We need the ones that have the same slope, which is the first one and the last one. Number 3, two lines are perpendicular if they intersect to form right angles. So you have perpendicular lines if they form a right angle. Lines are perpendicular, have slopes that are opposites, and they have to be reciprocals. So the first slope is a -3. Circle the lines that are perpendicular, so we have to find opposite reciprocal slopes. The second slope is 3, third slope is -1/2. So let's think about what the reciprocal of 3 is going to be. The reciprocal of 3 is 1/3. And they also have to be opposites. One of them has to be positive, the other one has to be negative. So it has to be the last two equations, -1/3 and +3. Number 5, what is the equation of a line that is perpendicular to the line shown and it goes through the point 5,1? In order to figure out what line is perpendicular to this line, we need to figure out what the slope of this line is right now. So we have to pick points on our line and find the slope between the 2 points. So the slope of this line is 2/3. So now I need a slope of a line that's perpendicular to this one. So that means the slope is going to change to the opposite of 2/3, which is a negative, and the reciprocal of 2/3, which is 3/2. And then it has to pass through point 5,1. So y equals to mx plus b. We're going to use slope-intercept form to figure out what our b value is so we can find our equation of the line. So 1 is my y, m is -3/2 times x is my 5 plus b. So what is -3/2 times 5? So let's check. Negative 3 halves times 5 gives us negative 15/20, which equals to negative 7.5 plus b. Now we're going to add 7.5 to both sides of the equation, and we get b equals to 8.5. So this is my b value, and then the equation is y equals to negative 3 halves x plus 8.5. There's my equation of the line. Number 6. What is the equation of a line that is perpendicular to 5x plus 3y equals to 45, and it passes through point 54? Again, we need one that's perpendicular to this line, so we need to find the slope of this equation here before we can write the equation that is perpendicular to this one. So let's go ahead and subtract 5x from both sides of the equation. We end up with 3y equals to negative 5x plus 45. Divide everything by 3. Y equals to negative 5/3 x plus 15. So now the slope of this equation is negative 5/3. So we need a slope that's perpendicular to this one, so it has to be the opposite and the reciprocal. The opposite of negative 5/3 is a positive, and the reciprocal of 5/3 is 3/5. So there's my new slope. Now it has to pass through point 54. So here's your x value, your y value, our slope. So now we need to do the same thing as we did in number 5, and we need to find the y-intercept. So let's plug in our numbers into slope-intercept form. Y is 4, m is 3/5, x is 5, and then we have plus b. So what is 3/5 times 5? 3 times 5 is 15, divided by 5 is 3, so we end up with 4 equals to 3 plus 5b, and subtract 3 from both sides of the equation, and b equals to 1. So now we know our slope of the line and the y-intercept, so the equation is y equals to 3/5 x plus 1. Page 5, correlation coefficient. Find the correlation coefficient and the equation for the line of best fit for the data in the table. Let x be the price of a play ticket and y be the number of tickets sold. This could be our x and this could be our y. Round the slope and the y-intercept and the correlation coefficient to the nearest hundredth place. That's 2 numbers behind the decimal. So to find our correlation coefficient, we have to follow these steps on our calculator screen. So to get our correlation coefficient, we need to go to the home screen, go to 1U Docs, and then we need to add a list and spreadsheet page. In here, we're going to copy down this table on here. So this is my x column. You label the top column with x, go down to 1 and start labeling the rest of our table, or entering it in. All right, so our B column, you're going to label it y, and then enter in the data from the table from this table into your calculator. All right, so from here, we need to get some data from it. What is the line of best fit for our table here and our correlation coefficient? So select menu, and we need to find our statistics on this. So we're gonna push 4, then 1 stat calcs, and then 3 to linear regression. Now here, you need to push the center button so you can get a drop-down list. And in the drop-down list, you need to go ahead and select X for the X list, arrow down and select the center button, and select Y for the drop-down list for your Y values. And that's it. Now go ahead and get your cursor and move it to OK and click on it. And then your data will pop up here. So right here in this row, that is our M value, which is our slope. It also has it down here. And then this is our B, which is our y-intercept. And then R is our correlation coefficient. So now we're going to go ahead and write some stuff down on here for us. So our M is our slope. It says to round it to the nearest hundredth place, so I want 2 numbers behind the decimal, so it's going to be negative 3.61. Then our y-intercept is our B value. Round to our hundredth place, so that's going to round off to 200.85. So the equation of the line is y equals to negative 3.61 plus 200.85. Our correlation coefficient is negative 0.99. This means we have a negative trend and it's a pretty strong correlation for our data here. Page 6, scatter plots. Number 1, draw a line of best fit on the scatter plot below. Which equation best represents line of best fit for your scatter plot? Let me show you a little trick on how to draw your trend line. So you want to outline your data. So there's the uppermost data. Outline the bottom of our data here. So you're kind of framing it out. So now your trend line is going to go right through that data here. So it's going to be right in the center. So then there's our trend line. So there we go. The red line is our trend line for this data. So now from here, we need to find out, well, what's the y-intercept? Somewhere right here on our y-axis, somewhere right above 200. So let's look at all these equations that are in slope-intercept form. This means the y-intercept is 35. That's too small. The y-intercept for b would be 0. That wouldn't work. And then we have 245 and 245. Both of those would work for our y-intercept. And as you can see here, you can pick 2 points on our line and then figure out our slope of the line. But if you notice here, one of these slopes is a negative, the other one's a positive. So then therefore you could just look at the line, line's going up. That means that the slope of the line would be a positive number, so it can't be a negative, so the answer would have to be D. Number 2, a teacher surveyed her students about the amount of physical activity they get each week. She then had her body mass index measured, make a scatter plot of the data. So we're going to put active hours on our x-axis, and on our y-axis we're going to put the BMI. Now our x values need to go up to at least 10, so we're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my y-axis needs to go up to at least 25, so I'm going to skip every other line, and I'm going to label every other line by 5s. All right, now we're ready to go ahead and plot our data. So let's plot the first one, 10 up to 17. 10 goes up to 15. 17 would be probably around here. Okay, so now we do 3, 25. 3 up to 25. 6 to 22. 8 to 19. 10 to 16. 8 to 18. And 7 to 20. And there's our data there. Can you see what kind of trend is happening to this data? Our data is going in a downward trend. So this is a negative trend. Has a negative correlation. True or false? The BMI is always higher than the number of active hours. Is the list of BMI always greater than the list of active hours? Yes, they are, so this is a true statement. There appears to be a positive trend between the active hours and the BMI. Well, this is a negative trend, so that's not true, that is false. The active hours are ranging from 3 to 10. So here's my active hours. They're going from 3 and to 10, so yeah, that's true. There appears to be a negative trend between the active hours and the BMI. Yep, this is definitely a negative trend, so that's true. And then the BMI ranges from 17 to 20. Well, this bottom one right here was 17, and then the uppermost one is 25. So it's going from 17 to 25 on our table. So nope, it's not going to 20, it's going up to 25. So this is false. Page 7's sequences. So for sequences, we have our two formulas, our recursive formula and our explicit formula. The recursive formula, the only thing you need to know is your D value, which is your common difference. And then the explicit formula, you need to know your A of 1, which is your first term, and then D, your common difference. Those are the only two values that will be replaced based on the situation or the problem. Number 1, the first 6 terms in an arithmetic sequence are shown below. 5, 8, 11, etc. Write the recursive formula for the sequence. So to write the recursive formula, we need to know what the D value is. What is the common difference? So what is happening to 5 to get to 8? Is this an arithmetic sequence? That means it's going to be either increasing or decreasing. So this is increasing by 3, 8, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14, etc. So that works. So therefore my common difference is 3. So now we're going to write the formula. A of n equals to A of n minus 1 plus 3. If the common difference was a negative number plus a negative number, then you would put a minus 3 here. Write an explicit formula for the sequence. So for the explicit formula, we need to know what the first term of our sequence is. And the first term in our sequence is 5. So that's A of 1. So to start writing our explicit formula, A of n is equal to the first term, which is 5, plus n minus 1. Just continue writing what we have here. And then times d, our common difference, which is 3. And you can leave 3 outside the parentheses, or you could even put it inside parentheses on its own. If it's a negative number, you need to make sure you put it inside the parentheses. Use the explicit formula to find the 15th term in our sequence. The 15th term represents our n value. So we can use either, let's use the explicit formula. So we're going to plug in n, 15 for n, so we get A of 15 equals to 5 plus 15 minus 1 times 3. So now you have to solve this. Now remember, when you solve this expression on the right, then you need to follow the order of operations. PEMDAS, please excuse my dear Aunt Sally. So let's go ahead and let's solve what's inside the parentheses first. 15 minus 1 is 14, and then times 3. Now we don't add first, we have to multiply first. So 14 times 3 will give us, you could check it on your calculator if you need to, 14 times 3 gives us 42. And then now bring down the 5, and then 5 plus 42 is 47. So the 15th term in the sequence is 47. Determine the first 5 terms of the sequence. And the recursive formula is given to us right here, and it tells us what the first value of the sequence is. The part of the recursive formula that we need to know is this minus 5, which is our common difference. That means that our sequence will be decreasing by 5 units every single time. So our first term is 23, and then we have to subtract 5. So 23 minus 5 will give us 18. Subtract 5 again, 18 minus 5, 13. Subtract 5 again, 13 minus 5 is 8. Subtract 5 again, and we get 3. And there's our first 5 terms of the sequence. Number 3, the pattern of squares below continues. More squares are added to each step n. So in our first step, we have 1 square. Our second step, we have 3 squares. Third step, we have 5 squares. Fourth step, you have 7 squares. So if you want to, you can look at it as a table. How many squares are in the first step? 1. Second step, 3. Third step, 5. And fourth step, 7. So there's our pattern here. It's our sequence. Our sequence is 1, 3, 5, 7. You can also look at it like that. 3, 5, 7. So now let's go ahead and write our explicit formula to represent the pattern. So in the explicit formula, all we need to substitute is our first term in the sequence and our common difference. So the first term in our sequence here is going to be the 1. So A of 1 is equal to 1. Let's write our formula. Start with A of n equals to 1 plus, and then let's continue with the formula that we have up here, n minus 1 times the common difference. The common difference is the pattern. How is this changing by? 1 to 3, 3 to 5, 5 to 7. It's increasing by 2. So our common difference is 2. So we're going to multiply this times 2. And there is your explicit formula. So now let's convert the explicit formula into slope-intercept form. So to do that, we have parentheses. We have 2 outside the parentheses. So that means we need to distribute the 2 to each of the terms inside the parentheses. So we get 1 plus 2 times n is 2n. 2 times negative 1 is minus 2. And then let's combine our 2 like terms here. So we have 2n. Negative 2 plus 1 is negative 1. So A of n is equal to 2n minus 1. There's my slope-intercept form formula. That's what we're doing here. Now you can use either of these formulas to find how many squares will be used for the 10th step. So this means that when n equals to 10. So we're going to substitute. I'm going to go ahead and use the second formula down here, the slope-intercept form. A of 10 equals to 2 times 10 minus 1. 2 times 10 is 20, and 20 minus 1 is 19. So there is how many squares will be in the 10th step? Page 8, systems of equations. A parking lot has twice as many cars as trucks. The total number of cars and trucks in the parking lot is 24. Write a system of equations that can be used to represent the situation. Let C represent the number of cars and T represent the number of trucks. So if you look at this sentence, it tells us what the total number of cars and trucks are in the parking lot. So the total of 24 cars plus trucks is equal to a total of 24 cars and trucks. If you look at the first sentence, it tells us that there's twice as many cars as trucks. Well, what does this mean? Well, obviously you have double the cars. So if you have cars and trucks, that means if you have 2 cars, there'll only be 1 truck. If you have 4 cars, there's only 2 trucks because it's double. Cars is double what trucks are. So if you have T trucks, you have to multiply it times 2 to equal to cars. So there's our second equation. 2T equals to the number of cars. Number 9, suppose you have 25 coins that total $2. Some coins are dimes and some are nickels. Write a system of equations that you will use to represent the situation. Let D represent the number of dimes and N represent the number of nickels. Well, you have 25 nickels and dimes. So nickels plus the number of dimes equals to 25 coins in all. And then you know that they total of $2. So what's the price of a nickel? What is the value of a nickel worth? It's worth 5 cents times the number of nickels plus the value of a dime is 10 cents times the dimes for a total of $2. You can write 0.1 for 10 cents, or you can even write it as just 10 cents, 0.10D. Either or works. Number 3, graph the system of linear equations. And then we need to find out how many solutions it has and what is the solution to the system. So I'm going to take the first equation. We get x plus y equals to 4. We need to convert it into slope-intercept form so that way I can figure out what my, so I can graph it. So we have negative x plus 4. So my y-intercept is at 4. And my slope here is negative x. That means my slope is negative 1 over 1, which means we're going to go down 1 and right 1. And there's our first line. All right, the second equation, we have 2x minus y equals to 2. So we have 2x minus y equals to 2, and let's convert that one into slope-intercept form as well. So let's subtract 2x from both sides of the equation. We're going to end up with negative y equals to negative 2x plus 2. Can't have a negative y, so we're going to get rid of it by dividing every term by negative 1. So we end up with y equals to negative 2 divided by negative 2 is a positive 2, and 2 divided by negative 1 is negative 2. So there's our second equation. So it's down at y-intercept is at negative 2, and then our slope is 2, which means we're going to go up 2 units and run to the right 1 unit. Up 2, right 1. All right, there's our second line. Now the question is, how many solutions does the system have? Where the lines intersect is the solution to the system. So it only has one solution. Well, what is it? What is the solution to the system? This is, you have to write your x value first, which is at 2, and the y value at positive 2. Now, anytime you encounter a problem with solving systems, you can always use your calculator to check it. So from a calculator page, you push menu, and 3 for algebra, and 2 for solving systems. So you want 2 equations. The variables we're using are x and y, and then we select OK. In the first one, we're going to write down this first equation right here, the original way that was written. So we get x plus 4, x plus y equals to 4. And the second equation is 2x minus y equals 2. And then you push enter, and it tells you your solution to the system, which is the same one that we got over here. So we are correct. Page 9, number 4. What is the solution to the system? Y equals to 5/4 x minus 5 and 3x minus 4y equals to 20. So what I'm going to do is I'm going to go ahead and use substitution method to help me solve my equation. We're going to substitute 5/4 x minus 5 in for y into the second equation. So we end up with 3x minus 4 times 5/4 x minus 5 all equals to 20. Now we have to solve the equation. So let's begin solving it. 3x, negative 4, we have to distribute it to each of the terms inside the parentheses. Negative 4 times 5/4 will give us negative 24, which is negative 5. Negative 4 times negative 5 is positive 20, and then equals to 20. Combine like terms, 3x's minus 5x's is negative 2x, plus 20 equals to 20. Subtract 20 from both sides of the equation, and we end up with negative 2x equals to 0. Now divide everything by negative 2, and 0 divided by negative 2 will give us 0. So there's our x value. So now we're going to use our x value and plug it in for the x value to the original equation, the one on top. So let's go ahead and we get y equals to 5/4 times 0 minus 5. Now we have to solve that. 5/4 times 0 is 0, and 0 minus 5 is negative 5. So the solution to the system is at 0, comma, negative 5. The x value is 0, the y value is negative 5. Again, you can use your calculator to check your work. Menu 3, 2. And let's enter in our two equations, the original ones that we have here. So we have y equals, and then 5/4 x minus 5, and then 3x minus 4y equals to 20. Push enter, and it tells us what our solution to the system is, which is the same one we got here. Number 5, tickets to the carnival for 2 adults and 4 children cost $36. An adult ticket costs 3 more than a child ticket. Write and solve a system of equations to find the price of an adult and child ticket. Well, our first sentence tells us that 2 adult tickets and 2 children tickets will cost $36. I'm going to go ahead and use A for adults and C for children. So we have 2A plus 4C equals to a total of $36. The second sentence will give us our second equation. An adult ticket costs 3 more than a child ticket. So an adult ticket is equal to 3 more than a child one. So child plus 3 will give us our price of an adult ticket. So now I'm going to go ahead and use the substitution method again for this one, since one of them has a variable solved for. If they were both in standard form, then I would go ahead and use an elimination method, but we don't need to. So let's go ahead and plug it in. So we get 2 times c plus 3 plus 4c equals to 36. Distribute. 2 times c is 2c. 2 times 3, 6, plus 4c equals to 36. 2c's plus 4c's, 6c plus 6 equals to 36. Subtract 6 from both sides of the equation, and we end up with 6c equals to 30. Divide both sides by 6, so we get c equals to 5. So now we're going to use that to plug into our equation here and help us find our a value. Oops, can't see that. So now we're going to get a equals to 5 plus 3. So a equals to 8. What does this mean in regards to the problem? It says to find the price of an adult and a child ticket. So a child ticket price cost $5 and an adult ticket price cost $8. Again, you can use your calculator to check your math and make sure you got it. You solved the equation correct, the system of equations correctly. Okay, but this time you can change your variables to A and C if you want, since we used those 2 variables to solve our problem. So, okay, let's go ahead and begin. Our first one was 2a plus 4c equals 36. Second equation, a equals to c plus 3. And then there's our answer. Adult. Last page, page 10. Y equals to 3x minus 5. We need to graph the system. So let's graph -5. Our slope is 3. So therefore we need to rise 3 and run to the right one. And then draw your line. Second equation is y equals to minus 3x equals to 2. So we need to move the x term to the right side. So we end up with y equals to 3x plus 2. So the y-intercept is at 2. And our slope again is 3. It's the same as the first one. And as you recall, if two lines have the same slope, then therefore the two lines are going to be parallel. If they're parallel to each other, then how many solutions does it have? It would be no solution because the lines will never intersect. If you enter in these equations into your calculator, you will also get no solution found. It would tell you that it's no solution. Number 7, graph the system. Let's go ahead and begin with the second equation since it's already in slope-intercept form. The y-intercept is at 1 and the slope is 1/2. So that means we need to rise 1, run 2. Okay, there's our first line. Our second equation is 2y minus x equals to 2. So when you convert it to slope-intercept form, so let's move the x term over to the right side of the equation, we get 2y equals to x plus 2. Divide everything by 2, we end up with y equals to 1/2 x plus 1. If you look at these two equations, they are exactly the same. Therefore, they are coinciding lines. They're going to be right on top of each other. And if they're coinciding lines, that means there will be infinitely many solutions. All right, algebra students, you are now finished reviewing for your semester exam. Make sure to show your test booklet, your review booklets to your teacher to get credit for it. And good luck on your exam on Monday.